Okay, so by my clock, it's time to start. So welcome to Introduction to Performance Tuning Perl Web Applications. I'm Perrin Harkins. And what we're going to do here, I'm going to give you a little overview of some of the tools I like to use when working on speeding up Perl web apps. We've got a black background because this is very serious stuff. And it is going to be an overview. It's a beginner level talk, but I think we'll get into some interesting stuff. So the first step is to find somebody you can blame. You know, I say that jokingly, but really it's about you need to figure out kind of where the problem is coming from. So a little definition here of terms, performance versus scalability. They're not really the same thing. People often talk about them in kind of the same sentence. Performance is more about the actual speed that somebody can bring up your web pages, and scalability is about how many simultaneous users you can actually support on the site. So often these can look like the same thing because you know, if you're having a scalability problem, it often results in your site being slow, or like a famous sort of death spiral sequence. But really, they're somewhat separate. And I'm mostly going to talk about performance in this talk. But a lot of the tools that you use for working on performance are applicable for scalability. By the way, the slides are going to be on the wiki afterwards, so don't worry about trying to write down you know, any URLs or things like that. And I'll be happy to take some questions at the end if there are some. Okay, so with performance, we're basically talking about slowness and how to fix it. And the first thing I would look at these days is maybe it's the designer, the guy down the hall who wrote the CSS. You know, his JavaScript is terrible. So, you know, what you need to do is find out, like, do you actually have a server-side problem or not? It's very easy these days to actually have a problem with, you know, something about the front-end code that's making the site appear slow. And the way that I usually try to figure that out these days is through the Chrome developer tools. You know, there's stuff in Firebug and other toolkits for this, but the Chrome stuff is nice. This is a little example of some of the stuff you can do. You can see, if you get into the network pane here, you can get this nice little timeline that tells you, like, you know, this is how long it took to actually get the HTML from this page, and then it'll tell you all the other resources and how long it took to render and things like that. So this is a nice way to check whether or not the server is slow. And if it turns out that you do have a front-end rendering problem, then you can get into something like the PageSpeed extension. This is a little report for Perl.com. It tells you some things that you might need to look at to speed things up. It's actually it's really just a checklist. It's not really looking at what makes things slow specifically for this page, but it's a useful starting point. You can see it looks like Perl.com did a pretty good job here, but some of these things are very obvious, like, you know, you should put width on your image and things like that, but it also does some stuff that's a little bit harder to figure out, like it'll tell you if you have CSS that's not being used and you know, that kind of thing. Okay, so once you've decided that you actually do have a server-side problem and you need to figure out how to deal with that, then you need to narrow it down further. First step in that, I figure, is usually creating a repeatable test. The reason for this is you need to know what your performance is at the beginning so that you can tell whether or not what you're doing is improving things. And you need to choose some metrics to compare. So usually that would be something like the number of requests per second that the site can handle. You could also get into the time it takes to handle, like, 100 requests, or well, in addition to that, you would need to determine what concurrency you're going to measure at, because it makes a big difference if you do them sequentially versus with 10 concurrent clients or 100 concurrent clients. So one simple way to get some numbers on that is the AB tool, which comes with Apache, and it's pretty commonly installed on many systems. This is a really simple command line tool. It basically just pounds one URL, and what I'm telling it with these parameters is concurrency 1 and do 100 requests. It can actually handle pretty high concurrency because it does a whole non-blocking I/O thing, and you can hit a URL pretty hard with that. And then you get a report back that gives you this kind of information. There's a lot of numbers here, but basically what's interesting in this is usually either the total time taken for the tests or possibly the requests per second. And it even gives you a little table breakdown of how the speeds fared over time. The next level up from AB is this tool called httperf. And by the way, there's tons of tools out there. These are just the ones that I happen to know and like. httperf is another command line tool. Pretty easy to get. There was a package for Ubuntu. I imagine there is for a lot of systems. And this can do quite a bit more. It has concepts built into it like think time between requests. It can do a burst to sort of simulate the way a browser actually interacts with a site, where it grabs the HTML and 20 images all at once. And it has a concept of sessions. So what I'm telling it here is I want to do 10 sessions. I want 5 bursts in each session, think time of 2 between them, start them up at a rate of 1 per second. I'm still just having it hit one URL here, though. You actually can feed this thing a whole list of URLs to hit in a special format, which tells it where the clusters are. And that's a pretty nice way to do it. You can do things like take an Apache log file and turn it into something to feed into httperf. And you get this kind of stuff as a result. Lots of juicy numbers. In here, you get the same kind of stuff back about like a reply rate. You also get some session information. Pretty soon it gets boring trying to write these little scripts that will test your performance. And rather than write them by hand, there's this nice module on CPAN called HTTP Recorder, which I like to use. It's a really nice little design. It basically starts a little daemon that acts as an HTTP proxy. And so what you do is you go in and configure your browser to point to the port that you started this up on, and then you go through the sequence of stuff you want to test on your site, and it generates a little mechanized script, which is nice. So that gets you a mech script. If you want to generate something for httperf because you want to really hit it hard with 1,000 simultaneous clients or something, there's also this other module, HTTP Recorder httperf, which will generate a session file to pass to httperf. So here's what a mechanized script generated by that might look like. This is like, go to a page, fill out a form, and follow it through. So this was all written automatically by Recorder. And then this is what a httperf output looks like. And you can see it's got all the calls nested together for a burst. And it's got things in there like, I think, time of 4 seconds, which it got by actually measuring the amount of time it took me between pages before I clicked the next link. So you can get a pretty nice simulation if what you want to do is simulate live users. If you need to actually figure out, where where things start to fall apart, you can use something called Autobench, which is a set of Perl scripts that run httperf for you. And basically what they do is notch it up like, with a concurrency of 10 more or whatever you set each time, and then create this nice graph at the end. So, I mean, that's more about scalability than about performance, but it's a neat little tool. Okay, so once you've got the repeatable test, then you need to find out, what is it that's actually slow. And the way you do that is to run a profiler. Now, these days, profiling in Perl means you'd use devel ytprof, which has been pretty much the only game in town for a few years now. And it does a really nice job. You can use this to measure CPU time or wall clock time or real time. And it used to be that all the profilers would default to CPU time, and we'd get all these people on the mob Perl list very confused, and we'd have to tell them to measure wall time instead. And the reason this matters is that if you're just counting CPU time, then you do get maybe a more accurate picture of how much time your own app actually spent on the CPU versus other simultaneous processes. But it doesn't count all the I/O time, all the time that you spent, waiting for something to come back over the network or waiting for a disk read. That all gets lost. So you get a very inaccurate picture unless you use wall time, at least for purposes of this, where we're trying to optimize how fast you really get the page. When you're doing a profile, you want to use your real environment or as close to it as possible. If you were to use like, a test database that doesn't have much in it, you'll probably get not very useful results. So you want it to be as close as you can, and ideally you want to profile in, the actual web server runtime environment that you're really using. It's also important to do multiple runs in one profile. Like, if you're trying to get a timing on a particular page, I would hit that page like 10 times and sort of average it out. That's good because it sort of clears up, random little glitches that might make it look like some particular piece is taking more time than it really is. And the other thing that's good to do is some kind of warm-up. This is because most of the time these days you're going to be using some kind of persistent Perl daemon, which does a bunch of compile stuff up front, but it doesn't do that on each request. So you don't really want to count all of that upfront preparation when you're profiling. And I wish that I could tell you like a simple recipe for, for how to do that. Unfortunately, it's really dependent on your system. There's lots of docs out there that say like, just use devel ytprof Apache, or use the plaque middleware, and everything will be fine. But if you really want to get useful results, I find you generally have to do a little bit of tweaking with ytprof in order to make sure that you're skipping the stuff you're not interested in. There's some stuff you can use in there about telling it when to start. There's like an enable profile and disable profile, and you kind of have to mess with that a little to get good results. So I've got one here to show you, which I did on some of my own code. This is from a little project I did for moveon.org, which is like an online ballot guide that shows you ballot races in your area and lets you say who you're going to vote for. So, it's your typical database-driven web app. And how many people here have used ytprof? Okay, great. Check out all this amazing stuff you get. I mean, this is like, we are living in an age of wonders with this thing. I mean, it's got, these are all the files that were used. In here, it's got a, breakdown. This is doing by subroutine the amount of time used. You can see basically what you want to look at is exclusive time, which is how much time was spent specifically in this sub and not in subs that it called, which is inclusive time. And then you can go down and look through each source file and get detailed stuff. And the stuff it gives you here is great. You can dive in here and it'll tell you how many times this was called, who's calling it. You can get a little per line timings. So that's really useful stuff. Of course, usually at the top is DBI execute, and all you're going to get here is this because it's actually C code, but it'll at least tell you relative to the rest how much time is being spent there, and you can tell actually in this profile result is a little bit unusual because the DBI execute stuff is only using a little bit more time than the thing behind it. Often what you'll find is like all the time is in DBI execute. But in this one, this is an app where it's not actually a slow app. The queries are pretty well optimized in this, so the other stuff can actually come in pretty close behind it. I have to show you this one more thing because I think it's so neat. You can generate this tree map. This is all the stuff going on here, so you can actually visually see how much time was spent in each thing. You can drill down in it. It's pretty awesome stuff. So allow. Okay, so you've got this great profiler. It's probably your database. The profiler is awesome, though. It'll tell you if there's something weird going on. So every now and then you'll find something. You'll find maybe there's a bad regex that's sucking up a lot of time. Like you've got a variable you're putting in there. It's making it recompile every time. Maybe you have a string you're parsing over and over that you didn't realize. Sometimes this will happen with your config files being re-evaled or something like that, or a massive object instantiation. Maybe you create 50 objects for every row you load from the database. Or sometimes you'll be waiting on network operations. If you've got some HTTP fetches, things like that, memcached, or good old-fashioned disk reads. But yeah, mostly it's going to be the database. So, it makes sense, right? Because what's the slow part in modern computing? It's not the awesomely fast CPU or the 8 gigs of RAM. It's the I/O of stuff. And what does most of the I/O in a web app? It's pretty much the database. So either you got to fix your queries or you have to cache them. So the next step then is to find out, well, which queries do you need to fix? And DBI actually has some great profiling stuff built in, which has been there for quite a while. It's very easy to use. You just have to set an environment variable before you start up your application, and then this is using something that collects the data for Apache and dumps it when you shut the server down. But there's lots of different options for how you can do this. So I've got one of these to show you too. So here is a DBI profile result. And you can see it shows you stuff like the number of times this query was called, the total time spent working on this query. How's that? I think we can go even bigger. There we go. Okay, so you get a lot of data from this, and I've got it ordered by the default here, which is by the total time. It's usually what you care about is where the most time's being spent. And what's good about this is it will tell you when something non-intuitive is going on. Like if I were to just guess what needs to work, I would probably think like, oh, it's this big query here probably that's slow, or maybe even this big query. But if you actually look at the results from this, you can see, in fact, this big query is taking less time than my session loading. So it's probably a dumb idea to work on speeding that up. It's already fast enough. So it helps you focus your resources on what is actually taking the time. Okay, so in terms of speeding up queries, I mean, this is a little beyond a YAPC talk, because it's really about knowing your particular database, and it's very database specific. But probably you're going to get into some explain plans. You're going to look at how it's using your indexes, and try to improve that. If you happen to be using MySQL, there's a tool that can be a good starting point in the Percona toolkit, which is called PT Query Advisor. It'll just tell you if you're doing something that is known to be a problem, joining a certain way, or something like that. Another thing you've got to remember is that SQL generation from DBI wrappers and ORMs is great for simple stuff, saves you a lot of time and a lot of boilerplate, but it's not for everything. There's going to be some times when you actually have to write a query manually, because you need to give it hints on which index to use and things like that. So that's why it's always important with your ORM to know how to get out of it and do a manual query. You also may have to do a little bit of database server tuning. If you're in an environment where nobody is the DBA and you're a little unsure of how to begin tuning your database, it actually doesn't take very much to make an improvement if no one has done anything yet. There's a nice little tool for MySQL, again from Percona Toolkit, called PT Variable Advisor, that'll just tell you the most obvious stuff that you should fix. But basically, if you were to spend an hour tuning an untuned database server, you'd probably improve things. Now I'm going to give you kind of the greatest hits of of how to speed up DBI stuff. There's a lot of information about speeding up DBI, which is available in Tim Bunce's slides, his advanced DBI talk on CPAN. I'll mention that at the end. But basically, that will give you all the stuff about use this method, not that method, and but that stuff isn't going to save a slow application. The thing that's going to make a big difference is things like this. So caching your connections and statements. In some databases, preparing a statement handle is actually slow, like Oracle. So caching that stuff can help a lot. Probably most of you are using some kind of DBI framework that does this for you. You need to manage your commits. It can be useful to do auto commit for some things, but if you have a lot of updates or a lot of inserts that you're going to do, turning off auto commit for that section can make a really big difference in most databases. And if you have really a lot of data, you probably want to jump out of there and use the native bulk loading tools for your database. I've actually found that with MySQL, it's faster to use text CSV XS, write out 100,000 rows to a CSV file, and then load them up with load data in file than it is to use like the best sort of multi-row insert syntax in MySQL. It's like much faster. So as soon as you get into bulk loading, you probably want to look at stepping outside DBI stuff. Okay, so once you're done trying to tune your queries, the place you end up is caching. Cache management is not that easy. I often encounter people who have just started using caching and they're really excited about it, and they talk about how like we're going to do all this invalidation stuff and it's going to we're going to have like a totally up-to-date cached copy of everything, and it'll be just like the database, only faster. The thing is, like, if that was actually possible, then the database would just do that, you know. So the reality is you're making some trade-offs somewhere when you're caching. One trade-off you're going to make is your code is going to get a lot more complex. A reason for that, besides just, you know, the sort of basic get and set calls, is you'll end up with all this stuff where you've got to invalidate stuff from your cache because people have made it, you know, there's like a change in the CMS, so you've got to, you know, go in and invalidate all these caches where that was being saved. And then after that, you quickly get into dependency tracking, where you're like, well, you know, this piece of data is also being used by this other thing, so if we invalidate these, we've got to cascade over and invalidate those. And, you know, pretty soon it gets very complicated, and your content creators get really mad at you. I remember having conversations with people where they'd come in and they'd be like, well, you know, I updated the price on this book 10 minutes ago and it still hasn't changed on the website, and, you know, they're going nuts. And you're like, well, let's see, there's like the database row cache has a 5-minute timeout, and then the object cache has a 10-minute timeout, and then the page cache has a, you know, and it just, you know, it really gets irritating for them, and it becomes very complicated. So, you know, you have to try to keep it to something that is reasonably simple to manage, and usually that means you're not going to, it's not going to be a perfect cache. You're going to have probably some stale content served sometimes, and maybe you'll invalidate a lot more than you need to in order to be safe, like, you know, kill large parts of the cache, rather than do a super fancy system to figure out, you know, what should be removed. Anyway, when you do cache, I recommend that you use CHI or Chi, which is a CPAN module for basically abstracting what you're actually using to store the data in the cache. And it's useful to have that because basically because memcached is not the silver bullet for every application. There can be times when something is actually better stored you know, in memory because you need it really fast, or it's worthless, or you know, maybe it doesn't matter if it takes a little bit longer to get, as long as it doesn't hit the database. You can, you know, there's a lot of choices you can make with CHI, and you get to change your mind later on. That way, you're not, you know, stuck with the one particular cache that was hot at the time that you know, wrote your system. So let me say just a little bit about the runtime environment that you're running your app in. Web server performance is generally not a very significant part of your app's performance. You know, you can run like Apache 1 on you know, some pretty old hardware and serve a ton of static content very fast. And you know, these days there's lots of ways you can offload that to S3 or, you know, something else. So that tends not to be a very big issue. So, which is great, because what that means is you can make your choice about web servers based on other criteria, like, you know, which one do you actually like? what do the people you're working with have experience with. You don't really need to be freaked out about, I've got to use, Nginx because it's 10 times faster. You don't really. You can use whichever one you find most useful. But there's a couple things that you do need to get right about your Perl environment. The most obvious one is running inside some kind of persistent daemon system. That might be mod Perl, it might be Plack and mod Perl, might be fast CGI. You have a lot of choices these days, and it's, again, it doesn't matter that much performance-wise which one you choose. So really, this is a decision you should make based on, which one you happen to like for other reasons. And whichever one you're using, you need to make sure that it buffers the output in some way. Fast CGI already has this, built in. It's got, this separate daemons and then the front-end web server. So the stuff gets generated on the back end and sent to the web server, and then spooled out to the clients from there. The reason why this is important is because if you get a bunch of slow clients coming in, you don't want them to tie up your Perl processes that could be generating more content, handling more clients. Instead, you want that to go to something lightweight up front. So if you're using Plack, I think most people would run some kind of proxy in front of that. With mod Perl, you definitely want to run a proxy server in front, either like another lightweight Apache with mod proxy, or some other kind of Nginx or similar. And you're going to want to do some kind of size limiting on your processes, which just means set something so when they hit a certain size, they should be killed and restarted, or some kind of restart every 100 requests. I used to feel kind of bad about this stuff, like, oh no, it's so such a crappy environment that we have to do this. But actually, what I've discovered is basically everybody does this in every language. It's not like a Perl issue exactly. It's just a general thing that happens with with web code and persistent daemons. So you have to set something up for that. And I would also point out that a lot of people think that's memory leaks. It's typically not actually a memory leak. It's just, as your program uses more data over time, it tends to need more memory, and Perl doesn't give the memory back when it's done. So, eventually the thing reaches a certain size, and in order to reclaim that memory, you've got to kill it and start a new one. So this is all great, but when you have a performance problem in the real world, the situation can be different. Usually what's happening then is flailing. So my definition of flailing is when you're changing things in your code based on guesses rather than on actual data. And, this happens all the time. There's something slow and everybody's running around like, try moving the sessions over to the, the other database, and people are like making changes. There's no QA going on at all. The programmers are maybe like looking at it for 5 minutes before pushing it live. And so what you get in this situation is a lot of collateral damage. You end up breaking things. I bet a lot of you have experienced this. I definitely have. It's a frustrating situation, and the best I can tell you is like to don't panic, and try to have a couple tools in your back pocket that are good for figuring out what's going on. I think actually there's a talk later today about debugging in production, which might be useful. But one thing that I find useful is what I think of as emergency profiling. This is where you stick in some like time high res print statements to figure out like how much time you're spending in different sections. And there's actually some nice modules to make that really easy, like benchmark Stopwatch is a nice one. So the way that this thing works is you tell it, I just finished, with this lap command, you tell it like, I just finished loading my objects, I just finished rendering my template, and then you print a summary, so you could like dump this to your weblog or something. And in the summary, it'll tell you like, well, this is the percentage of your time that you spent on each of those things. So you could use this and just kind of like narrow down, what's actually going wrong in my system. Another thing that comes up in in this situation in the real world is doubts about your infrastructure choices. So you'll ask somebody for help, and they'll be like, "Oh my God, you're using Dancer template toolkit, DBIX whatever. I can't believe you're using that. It's so slow. Of course it's slow." And keep your head when this happens. A lot of people will tell you this without really a lot of basis for what they're saying, just because they happen to, like one tool over another. The thing is, if you're using like a popular CPAN module, the odds that it is, actually very slow are slim to none. It's any like mature and popular CPAN thing has been through, enough that probably the real slow stuff has been worked out of it. So, don't immediately assume that, just because you were told that, like Xlate is 10 times faster than Template Toolkit and you've got to switch, and, like spend the night porting your code over. If you do find that in your profile, you actually see something showing up there, then the first thing I would do, rather than attempting to like switch immediately, is to try to get help and find out if you're just doing something silly that's causing the performance problem. There might be a FAQ about that. I would Google Template Toolkit performance or something like that, and go and check on the mailing list, see if there's an IRC channel. Basically, there's a pretty good chance if something seems to be performing less than you'd expect that that there's a reason for it and it's not that hard to fix. There used to be a bunch of people who would come into the Template Toolkit mailing list periodically and say, like, it's so slow, what can I do? And it would turn out that they were using it in a way that defeated the cache. And, it's like 10 times slower when you do that. So like a simple fix, and suddenly, everything is much faster. Another thing that will come up is buying hardware, which is a great idea. Often the fastest and cheapest way to fix a performance problem. A boatload of RAM hides a multitude of sins, and also an SSD RAID fixes a lot of database problems. The place I'm working now, we just keep getting like more and more awesome database hardware, and every time I think we're going to have to do something crazy and like try out one of the new column-oriented databases or something, it turns out that nope, you can just buy another rack of SSDs and the problem goes away for another year. So the one thing to do, though, is make sure that you actually know what the bottleneck is, because it's of course it's easy to buy the wrong thing. You need to know, is my problem that the disks are slow or that I'm running out of RAM? I have worked at places where like somebody would come in like really proud of the new web servers that they ordered, like, oh, check out these specs, and they've got these awesome CPUs, and I'd be like, well, that's great, but actually we never touch the CPUs on the web. It's basically all RAM that is the bottleneck. So you need to know what it is that you're trying to fix. Okay, so just a couple quick things that you might check out. I mentioned before Tim Bunce's advanced DBI slides. Those are really good, and it'll tell you like way more than you ever wanted to know about the most efficient calls for DBI. But again, for the most part, we're talking like it'll make like a 5% difference, something like that. It's not going to be the difference between fast and slow, but it's still totally worth knowing, especially for writing new code. And I also think the Percona toolkit is pretty cool. It does have a lot of MySQL stuff, but it also has some general system tools. There's like a fancy IO stat replacement and for checking your disk activity. And there's a few other things in there that are just generally useful for analyzing performance problems. So that's what I have for slides. Any questions? Mm-hmm. Yeah. So the question is, in my example, I was running like httperf against localhost, and would it make a difference to run that on a separate machine? It definitely would. I mean, I was doing that for because I was able to set that up right here and get something to show while I was at the conference. But in reality, you definitely would not want to run the load tester from the same machine. There's actually, because these things use a lot of CPU, I think there's like an option called --hog for httperf, where it will like use up all of your ports and really slam your machine, but then you can do an awesome amount of load. These things really, like, you can crush most websites by running AB or httperf until they figure it out and block you. So, okay, other questions?
Can you go back one slide?
Mm-hmm. Yeah. Yeah. Okay. So the question is, where is good information about setting up NYT-Prof? So, I mean, the CPAN docs are reasonably good. The NYT-Prof Apache stuff has some information about how to set it up. But if you're working on it with Perl, I would suggest coming over to the Perl mailing list and getting some direct help. If
specifically things like what you're talking about, like enable profile, disable profile, because I've done it, but like register is right at the top, and like I haven't like starting.
Yeah, you get like crummy results until you tweak it a little bit. So I don't know of anything that is already out there that really explains how to do it nicely. And what I think I want to do is try to improve the CPAN docs, because that's the place that people should be looking. So I had a little trouble getting good results with it for this demo. So I think what I'm going to do is just try to send in some patches for that and try to improve the basic docs. But yeah, definitely come to the Perl list and show us what you're getting, and probably somebody can help you figure it out. Other questions? So the question is it easier to do it in Plaque, and would that be a better option than trying to make it work in Perl? Honestly, I haven't actually tried profiling in Plaque because I don't have a production Plaque application. But My guess would be yes. It's probably pretty nice, but the thing about it is that generally you're trying to fix an application that you have, and a lot of people have stuff that's already running in mod Perl, so it needs to work in mod Perl. Anything else? Okay, if you think of something and want to come up and chat afterward, that's totally fine. Thanks, everybody.